Third form Trinity exam 2019, the non-calculator paper. So question 1, we're given this fact here, and bearing this in mind, we've got to work this out. Now you can just sort of try and manipulate the decimal point, just bearing in mind these numbers, and do it that way. But my preferred method for this is just to treat it as an estimating question. So let's estimate what this is and use that information to choose where we put the decimal point, because we know it's going to be these digits times these digits, these times these, giving us these digits. It's just a question of where we put the decimal point. So let's estimate what this is. So 26.34 rounded to one significant figure is 30. 470 rounded to one significant figure is 500. 30 times 500, well 3 5s are 15, and add the 3 zeros. So we know that the answer to this is roughly 15,000. Now the answer comprises these digits, so where are we going to put the decimal point to get an answer of approximately 15,000? Well, it's going to be between the 9 and the 8, giving us £12,379.80. Now part B, the same idea. We've got these digits divided by these digits, giving us these digits. So our answer is going to be 2634, and it's just a question of where we put the decimal point or add some zeros. So let's estimate this. So 123,798 to one significant figure is 100,000. 4.7 is 5. 100,000 divided by 5 gives us 20,000. So where are we going to put the decimal point or add zeros with these four digits in order to get an answer of roughly 20,000? Well, we're going to be adding a zero to give us 26,340. Question 2. So a similar approach to question 1. Let's round each of these numbers to one significant figure to start with. So 498 becomes 500, 21.3 becomes 20, and be careful with this one, 0.504 becomes 0.5. Don't round it to 1, that's sort of doubling it, that's not approximate at all. So we've now just got to work out what this is. Well, clearly the numerator, 500 times 20, 2 5s are 10, and add the 3 noughts, giving us 10,000. Now be careful here, this is how many halves can you fit into 10,000, which is going to be 20,000. Okay, it's not 10,000 divided by 2, it's being divided by a half. If you like, just double top and bottom to make it clearer. So doubling the top we get 20,000, doubling the bottom we get 1. 20,000 over 1 is 20,000. Question 3, so we have to substitute in these values. So u is 40 times t, which is 10. So remember, ut means u times t, so that's 40 times 10, giving us 400. And then our second term is half times a times t squared. So half times minus 4 times 10 squared. So remember bid maths, so do the indices first. 10 squared is 100. Half of 100 is 50. 50 times minus 4 is minus 200. So we've got 400 minus 200, which is 200. Question 4. So we're going to factorize this and then solve it. So remember, factorizing means putting in the brackets. And when we have a quadratic equation like this, so we've got some x squareds and some x's and a number, our factorizing, our brackets comprises a pair of brackets, and in order to get the x squared we're going to need to have the x times the x. So it's all a question of how we work out these two magic numbers here. Now these magic numbers have to multiply to give us the term on the end. Now be careful, that's minus 24. So what numbers multiply to make minus 24, but at the same time add to make the coefficient of the x, so add to make plus 2. So two numbers which multiply to make minus 24 but add to be 2, and that's going to be 6 and minus 4. 6 times minus 4 is minus 24, but 6 added together with minus 4 is plus 2. So our two magic numbers are plus 6 and minus 4. So at this point we factorized it. That is it fully factorized, and once it's factorized it's very easy to solve. We're saying we've got this bracket times this bracket equaling 0. So when the first bracket equals 0, 0 lots of whatever are 0, and similarly when the second bracket is 0, whatever times 0 is 0. So how do we make in turn each of the brackets equal to 0? Well, how do we make this first bracket 0? That is when x equals minus 6. Minus 6 add 6 being 0. Or alternatively, how do we make the second bracket 0? That is when x equals plus 4. So our two solutions are minus 6 and plus 4. Question 5. So here are the first 5 terms in an arithmetic sequence. We're told that the nth term rule for this. Is 98 a term in the sequence? So remember how the nth term expression works. This gives us the link between the position in the sequence and the number itself. For example, this 18, that's 5th in line. So that's position 5. So that is when n equals 5. So how could we work out this 18 from the expression? We would substitute 5 into this. 4 5s are 20. Take away 2 to give us the 18. Now what we're saying is 98 actually in this sequence? So is there a position in the sequence such that we get the answer 98? So in order to establish that, we set our expression equaling to 98 and we solve to find n. Now if n is a whole number, then it's a genuine position and we can say yes, 98 is in the sequence. But if n is not a whole number, then it is not. There is no such position in the sequence, so we can then conclude that 98 is not in the sequence. So let's solve this. So we add 2 to both sides, divide by 4, and we get n equaling 25. So what I should have written here, and I forgot to write it down, is 98 a term in the sequence? Yes, it is. It is the 25th term in the sequence. So that needs to have been written down. I forgot to write down here that yes, it is. It's the 25th term. Question 6. So we've got to make t the subject. So we've got to move from the formula being v equaling something to t equaling something. So we've got to manipulate this. So start off by addressing the term which is furthest away from the t itself. So don't worry about the 5 yet. Start off by undoing the plussing of the u. So how do we undo plus u? We minus u from both sides. So at that point we get v minus u equaling 5t. Now all we've got to do now in order to have t on its own is to undo this timesing by 5 by dividing by 5. Now to make it clear that it's the whole of the v minus u being divided by 5, this is the best way to set it out, sort of create a fraction. So it's v minus u all over 5. So t equals v minus u all over 5. Question 7. So now, following on from question 6, we've now got to work out the nth term rule, the nth term expression. So the first part of the expression is we establish by how much we're going up each time as we move from one term to the next. So we can see we're going up in 6s. So the first part of the expression is 6n. Now we then need to have this little adjustment on the end. Now the easiest way to establish this is to think of what would be the 0th term. So 3 is the first term in the sequence, 9 is the second term, 15 is the third term, and so on. So what would be the term that becomes in front of the first term, so the 0th term? So as we're going from right to left, we can see we're taking away 6 each time. So what term would be here? Well, we take away 6 from 3, giving us minus 3. So that's this adjustment. So this is the nth term expression. And again, just to run over again how this works, this allows us to work out the relationship between the position in the sequence and the term itself. So for example, this 21, that's 4th position, first, second, third, fourth. So that's when n equals 4. 6 4s are 24. Take away the 3, we get the 21. So we can use this to work out any term we like. So the 100th term is when we substitute 100 into this expression. 6 times 100 is 600. Take away 3, 597. Question 8, part A. So we've got to simplify this surd into this format. So think of 2 numbers which multiply to make 45, but one of which is the biggest square that you can think of, such that when you times them together you get 45. So for example, 15 times 3 won't work because neither 15 nor 3 is a square number. However, 9 times 5 does, because 9 is a square number. So think of the 45 as 9 times 5. and then split the two numbers into its own separate square root. So that's the square root of 9 times the square root of 5. Now because 9 is a square number, the square root of it is a whole number. The square root of 9 is 3. So rather than root 9 times root 5, we're going to have 3 times root 5, which is 3 root 5. Now for part B, just think of this as 4 terms being multiplied together. 2 times root 12 times 5 times root 3. Now when you have various terms being multiplied together, you can change the order. 2 3s are 6, 3 2s are 6. So I can change the order. So put the whole numbers first. 2 times 5, and then the roots together, root 12 times root 3. Well, obviously 2 5s are 10. Now this is really the opposite to part A. We're now going to combine these under the same square root. So it's the square root of 12 3s, which is 36. So the root 12 times root 3 is root 36. Now what is the square root of 36? It's 6. 6 6s are 36. So this is 10 times 6, which is 60. Question 9, part A. Work out the size of each interior angle of a regular decagon. Now, a decagon has got 10 sides, but you could have just added them up if you didn't know that. Now, what do we know about the angles of regular shapes? Well, the exterior angles, that's the outside angles, always add up to 360. So if it's got 10 sides, so 10 exterior angles, then how much must each of them be, given in total they add up to 360? So 360 divided by the 10 angles means each of them is 36 degrees. Now that's the exterior angle. Now the exterior angle plus the interior angle always add up to 180 because they form a straight line. So given that the exterior angle is 36, the interior angle, that's the normal angles on the inside, is 180 take away 36, which is 144 degrees. Now part B, if we're told that each exterior angle is 20, like as I said earlier, they add up in total to 360. So if each of them is 20, then how many of them are there? How many exterior angles? How many sides? It's going to be 360 divided by the 20, giving us 18 sides. Question 10, part A, we've got to find the gradient of this line. Now the gradient is the slope. Now to work out the slope of a straight line, you have to divide its height by its base. So we need to form a triangle. Any triangle will do, but obviously just make it such that it's nice, simple whole numbers. So I've chosen this triangle here. So the height of that triangle is 4, the base is 2, 4 divided by 2 equals 2. So just to go over that again, the gradient, which is represented by the letter M, is the height of the triangle. We call that the y step, so that's 4 divided by the base, which is the x step, which is 2. 4 over 2 is 2. Now if we'd taken a different triangle, for example this triangle from here up to here down to here, that would be fine, because we would then have a y step of 6 and a base of 3. 6 divided by 3 is of course still 2. So it doesn't matter which triangle you use, because it's the ratio of the height to the base, so it doesn't matter because they're all similar triangles. So 2 is the gradient. Now, to find the equation of a straight line, always start off with sort of the skeleton format, if you like. An equation of a straight line is y equals mx plus c, where m is the gradient of the line, and we've already established that to be 2. So y is going to equal 2x. Now what does c represent? C is where the line crosses the y-axis, it's the y-intercept. So where does this line cross the y-axis? It crosses at -1, so c is -1. So the equation of the line is y equals 2x minus 1. Question 11. So we've got to prove algebraically that this recurring decimal can be written as this fraction. So our first step is to let x equal this, but sort of set it out in it, setting out the recurring elements. So the 4, 5 with the 2 dots means it's 4, 5 being repeated. So it's 0.0, 4, 5, 4, 5, 4, 5, and so on. Don't forget to put in the ... so people appreciate it goes on forever. Now, what we're going to choose to do is to multiply by 100. I'll explain why in a minute, but really your rule of thumb is if we've got the two dots next to each other, then multiply by 100, 2 zeros, 2 dots. Had there been just the one dot, then multiply by 10. So when we go and multiply both sides by 100, we get 100x equaling 4.545454 and so on. All the numbers have moved along 2 decimal places. Now, having done this, you will see that the recurring element is now lined up. The 4 lines up with the 4, the 5 with the 5, and so on. So what that means is if we take equation number 2, the second one, and subtract from this equation 1, we're actually going to remove the recurring element. So that's going to disappear. So 100x take away x is 99x. 4.5454 recurring, take away 0.04545 recurring, gives us exactly 4.5. Now, we want to make x the subject. Now, I want to try and avoid really the situation of dividing by 99 here, because we're then going to be saying x equals 4.5 over 99, and it's not very nice to have a decimal as part of a fraction. So really, to avoid this, I want us to choose to multiply at this point both sides by 10, so hence getting rid of the decimal point. So we're going to have 990x equaling 45. Now we can divide by 990 to make x the subject. So x is going to be 45 over 990. Divide top and bottom by 45. We get 1 over 22, which is indeed what we had to prove algebraically. Question 12. So Talil is going to make some concrete mix, and in order to make this, we mix cement, sand and gravel to create the concrete in the relationship, the ratio 1 to 3 to 5. So 1 to 3 to 5. So how many shares is that in total to make the concrete? That is 9 shares. Now we need to make 180 kilograms of concrete. So pop the 180 into the concrete column, and then you can see that that is 20 times our original ratio. 180 divided by 9 is 20. So in order to make 180 kilograms of concrete, we're going to need 20 lots of the cement, this sand and this gravel. So multiplying each of these by 3, we can find out how much we need of each. Sorry, multiplying each of these by 20, how much we need of each of these 3. So 1 times 20 is 20, 3 times 20 is 60, and 5 times 20 is 100. So that is how much we're going to need of each of the 3 ingredients. Now, how much have we got? We've got 15, 85 and 100. So you can see we do not have enough cement, we have more than enough sand, and we have exactly the right amount of gravel. So does Talil have enough of each of these? No, he doesn't. Talil does not have enough cement. Question 13. So we have to enlarge the shape by scale factor -2, centre 1, 2. So first thing, establish where the centre is. So that's at 1, 2. Now, we're going to make it twice as big, but it's going to be twice as far away in the opposite direction from this centre of enlargement. So take this point here, for example, which is presently 1 to the right of the centre of enlargement. We're going to double that and make it twice as far away, but to the left. So that's going to go from being 1 to the right to 2 to the left. Similarly, this point here, that's presently 1, 2, 3 to the right, so that's going to become 6 to the left. And this point here, which is 1 to the right and 1, 2, 3, 4 up, is going to become 2 to the left and 8 down. So here is our reflected shape, twice the size and twice as far away, but on the opposite side of the centre of enlargement. Question 14. So 2 different types of sandwich, cheese and ham, and we take at random 2 of these sandwiches, work out the probability that she takes at least 1 ham sandwich. So let's just do a probability tree for this. So as we take our first pick of sandwich, the chances of getting a cheese is 5 out of 7, and getting ham is 2 out of 7. Now, as we take our second sandwich, you've got to bear in mind that one's already gone. So let's consider the two scenarios when we've taken a first pick of cheese. Now, if a cheese is gone, there's only 4 cheese left out of a total of 6. So the probability of a cheese with our second pick is going to be 4 out of 6. But probability of a ham with our second pick, given we took a cheese first of all, is going to be 2 out of 6. Note how the two branches always add up to a whole. Now, what about if we've taken a ham with our first pick? The chances of getting a cheese with our second pick is 5 out of 6. But the chances of taking a ham with our second pick would be 1 out of 6. Now, we want to work out the probability that we take at least one ham sandwich, so that's going to be each of these 3 branches here. The cheese ham, ham cheese, and ham ham. So let's work out the probability of each of these 3. So how do we get cheese ham? We have a cheese and then a ham. 5/7 times 2/6. Top times top, bottom times bottom, giving us 10 over 42. What's the probability of getting a ham and then a cheese? That's 2/7 multiplied by 5/6, which is 10 over 42. And the ham option, 2/7 multiplied by 1/6, which is 2 out of 42. Now, we don't mind which of these 3 occur. We've just got to work out the probability it takes at least one ham sandwich. So it doesn't matter whether it's this one or this one or this one. Now, when it's an or, you add the fractions. So 10 over 42, add 10 over 42, add 2 over 42 is 22 over 42. If you want to simplify the answer, you didn't have to, but if you want to, that gives us 11 over 21. So the key point with probability trees, when it's an and, you multiply. So cheese and then a ham, that's when you multiply. But when it's an or, because we don't mind whether it was this or this or this, that's when you add the fractions. Question 15. So part A, draw a cumulative frequency graph for this information. Now, the key learning point here is when you plot the points, you take the upper bound for the coordinate. Okay, so we're going to be plotting 20, 25, and 30, 70, and 40, 138, and so on. So that's the key bit. So that gives us that sort of falling over S shape. So join the points together with a nice gentle curve. Now, part B, Graham says 10% of workers at the factory are older than 65. So let's go and work out whether this is true or not. So here's our 65 years of age. So take a reading from your graph, and I'm getting 192. So how many people are older than this? Well, that's taking us from 192 up to 200. So there are 8 people who are older than 65. Now, that's 8 out of 200 people. So that's 4%. So Graham is not right. There are not 10% of workers older than 65. There are 4%. Question 16. Now we're being asked to list the members of the set A intersection B. So that means which members are in both A and in B. So let's think of all the factors of 100. So that's 1, 2, 4, 5, 10, 20, 25, 50, and 100. Now, what about the multiples of 5? Well, those are obviously 5, 10, 15, 20, and so on. So which numbers are members of both of these lists? And we can see, so really we're looking for any multiples of 5 that are in these factors of 100. So the answers are 5, 10, 20, 25, 50, and 100. Question 17. So we have to really rearrange this as if it was an equal sign here. We just need to make x the subject. So I'm going to choose to add x to both sides to start with, to undo this minusing of x. So 4 is less than 3x minus 5. Now I'm going to add 5 to both sides to undo this minus 5. So at that point I've got 9 is less than 3x. And then to make x the subject, I'm going to divide both sides by 3 to undo this timesing by 3. So 3 is less than x. Now 3 is less than x, just sort of think of it as reading it from right to left. That's the same thing as x being greater than 3. Question 18. So think of the whole numbers being times together first of all. So 4 times 8 being 32. And now think about the powers of 10 being multiplied together. Now when we multiply, we add the indices. So 6 added together with minus 3 is 6 take away 3, which is plus 3. So we've got 32 times 10 to the power of 3. Now that would give us 1 mark, but the question requires us to give our answer in standard form. Now in standard form, the first number has got to be between 1 and 10. So in order for that to happen, we need this to be 3.2. So we're going to choose to divide the first number by 10. But we can't change the overall number, so if we're dividing the first number by 10, to offset this, we've got to choose to multiply the second number by 10. Because dividing by 10 and timesing by 10 cancels each other out, so overall the number isn't changed. Now think about multiplying this second term by 10, that's 10 to the power of 1. When we multiply, we add the powers, 3 add 1 equals 4. So that's 3.2 times 10 to the power of 4.